Welcome, business analytics students. If your exams are right around the corner and you're feeling totally overwhelmed by all these complex blockchain buzzwords, you are in the exact right place. In today's explainer, we're going to decode this entire technology. No confusing jargon, just pure, structured knowledge that's going to help you ace your exams and truly understand the future of business tech. Let's dive right in. Here's a quick look at our roadmap for today. We'll start with the basics and history, then compare traditional databases to blockchain. After that, we'll break down cryptography, the core architecture and pillars, dive into some real-world applications, and finally, wrap up with a quick revision and those all-important exam questions. All right, let's kick things off with Section 1, Demystifying the Basics and the History of Blockchain. So, the core textbook definition of a blockchain is a decentralized, immutable digital ledger of transactions distributed across a network. But what does that actually mean for us? Think of it like a shared Google Sheet for your MBA project group. Every single member has a copy, and everyone can see when new data is added. But here's the magic part. Nobody can go back and delete or secretly change past entries. It is completely transparent and permanently locked in. That's blockchain in a nutshell. Now, a lot of people think blockchain started with Bitcoin, but actually, if we look back to 1991, academics created the very first cryptographically secured chain of blocks. Then in 2008, the mysterious Satoshi Nakamoto published the famous Bitcoin white paper. Fast forward to 2015, Ethereum introduced smart contracts, which literally turned blockchain into a highly programmable business tool. And today, we are seeing massive enterprise applications rolled out across pretty much every industry. Moving on to Section 2, let's look at traditional databases versus blockchain and see how this actually solves real-world problems. This brings up the ultimate business analytics question. Why was this technology even created in the first place? What problem is it actually solving? Well, just think about the critical flaws of centralized trust. If your entire business relies on just one single database server, what happens if that server gets hacked? Or what if it goes offline during a power outage? That is a massive single point of failure. Think about a standard ATM transaction. In a traditional database model, your bank is the central authority. They own the server, they approve the transaction, and if their system is down, you're just not getting your cash. Blockchain flips this concept completely upside down. Because it's decentralized, instead of one bank server, you have thousands of peer-to-peer computers validating that transaction. There's zero middleman and absolutely no single point of failure. Let's jump into Section 3, the cryptography basics. This is the underlying math that makes all of this secure. Let's start with keys. On a blockchain, you have a public key and a private key. The easiest way to wrap your head around this is to think about WhatsApp's end-to-end encryption. Your public key is exactly like your phone number. You can give it out to anyone so they can send you a message, or in crypto's case, send you funds. But your private key, that is your highly guarded secret password. You use it to actually unlock those messages or authorize a transaction sending your funds elsewhere. You never, ever share your private key. Next up, we have digital signatures and digital certificates. A digital signature provides mathematical proof that a specific transaction was initiated by the true owner, and it does this without ever exposing their private key to the network. It essentially proves you sent it. Meanwhile, a digital certificate verifies the real-world identity behind that public key, ensuring you're actually doing business with exactly who you think you are. Now, let's talk about hashing, which is the absolute backbone of blockchain security. You can take any input data, like a single word or even an entire encyclopedia, and pass it through a mathematical algorithm. This generates a fixed-length string of characters called a hash. Here's the absolute exam-winning concept you need to remember. If you change even a tiny comma in that input data, the resulting hash output changes completely. Because of this, the network instantly knows if someone is trying to tamper with a record. Let's move into Section 4, covering the architecture and technical pillars. These are the structural pieces of the network. We have transactions, which are recorded on a distributed ledger. These transactions are then batched together into what we call blocks, and every single new block is mathematically linked to the previous block using that exact hashing process we just talked about. This creates a literal chain of blocks, hence the name, blockchain. But who is actually checking all of this? That's where nodes and mining come in. Nodes are simply the participant computers connected to the network, and mining is the heavy computational work those nodes do to validate transactions and lock them into the next block. In exchange for doing all this heavy mathematical lifting, the miners earn network rewards. They are the decentralized engine of trust for the whole system. You definitely want to memorize the 4 core pillars of blockchain: decentralization, transparency, security, and immutability. Decentralization means there's no central boss. Transparency means all participants can view the ledger. Security is heavily driven by cryptography. And immutability means that once records are written, they literally cannot be changed. Mark my words, this is a guaranteed short note question for your upcoming MBA exams. Section 5 is where things get super practical. Let's look at real-world business applications and the actual ROI. Let's look at how MBA-relevant industries are applying this right now. In banking, it's being used for instant cross-border payments. In healthcare, it's creating secure, unified patient records. In supply chain, you can track a product with total transparency from the factory floor all the way to the retail shelf. Education uses it to issue tamper-proof digital degrees, and e-governance is securing land registries so property records can't be illegally altered. Now, as future analysts, it is totally crucial for you to understand this major business distinction. Cryptocurrency is just the very first application built on the blockchain platform. Think of crypto as the app and blockchain as the underlying operating system running it. Do not mix those two up in your exam answers. And let's look at this locally. We have some fantastic real-world examples from India that you can absolutely use in your case studies. The RBI has launched its CBDC, the digital rupee. Several state governments are piloting blockchain for massive land registry projects, and Niti Aayog is actively pushing blockchain initiatives in both agriculture and healthcare. This adoption is happening at a massive scale right now. All right, we made it to section 6. Time for a quick revision and final exam prep. Let's do a rapid-fire summary. To really lock this in, anchor your understanding to our analogies. Blockchain is that distributed Google Sheet that nobody can delete. Public and private keys work just like giving out your phone number versus keeping your WhatsApp password a total secret. Hashing mathematically locks the data, and the network is kept running by nodes and miners. And whatever you do, do not forget those 4 pillars: decentralization, transparency, security, and immutability. Finally, here are the most likely exam questions you're going to face. Practice writing out the differences between traditional databases and blockchain. Be ready to explain those 4 pillars, detail how hashing secures the chain, and prep a really strong use case for supply chain or banking. Master these, and you are going to absolutely dominate your paper. But before you get back to studying, I want you to ask yourself, 10 years from now, when you are leading a major corporation, which parts of your business will you trust to a centralized server, and which parts will you secure on the blockchain? Good luck with your exams.